Hello, how are you? Welcome to my classes on rational number on the number system of chapter 1 of NCERT Cbse syllabus for class 9. So the previous classes we have studied what are rational numbers, then real numbers, whole numbers, integers, positive integers, negative integers, zero, all that. Now we are at a point where you are learning how do we represent, so what is irrational numbers and how do we represent the irrational numbers on the number line. All the numbers are on the number line, right? Irrespective of whatever they are, maybe whole numbers, rational numbers, or real numbers, or positive integers, negative integers, zero, or irrational numbers. All these numbers are available on the number line. So before that, we know what are irrational numbers. Let me revise and tell you what is irrational number. An irrational number is a number which cannot be represented in the form p by q, where q is not equal to 0 and p and q are integers. Okay, so this is the definition of irrational number. To repeat again, an irrational number is a number which cannot be represented in the form of p by q, where p and q are integers and q not equal to 0. This is one part of it. And now we got to know how do we represent these numbers on a number line. To understand that, we got to understand, or we have to recollect what we have learned in class 8, that is the Pythagoras theorem. The Pythagoras theorem is applicable on a right angled triangle. Okay, in a right angled triangle, what it means to say by a right angled triangle, there is one angle which is of measures 90 degrees. That is why it is called as a right angled triangle. So, as per the Pythagoras theorem, in a right angled triangle, the square on the hypotenuse is equal to the sum of the squares on the opposite side. What does it say? The square on the hypotenuse is equal to the sum of the squares on the opposite sides. Now, what is the hypotenuse? What is this hypotenuse? Hypotenuse is the side that is opposite to the right angle triangle, which stands opposite to the right angle triangle. So let us I'll show you what is a hypotenuse, what does exactly this Pythagoras theorem says. And remember, Pythagoras theorem is only applicable to a right angled triangle. So hold on. This is a right angle triangle which I have drawn already, and with the right 90 degree angle of 90 degrees, a right angle at A, which is does nothing but a line AB, for which there is a perpendicular line which stands at 90 degrees, that is AC, and I have joined BC. So now this line BC is called the hypotenuse, and these are the arms of this point of 90 degrees, of this angle 90 degrees. So these are the opposite sides. So what does the Pythagoras says? Pythagoras theorem says the square on the hypotenuse, that is BC square, is equal to the sum of the opposite sides. That is BC square is equal to AB square plus AC square. BC square is equal to AB square plus AC square. This is the exact definition of the Pythagoras theorem. So now we need to represent. So now we got to know how to represent square root of 2, right? So let us see how to represent the square root of 2 on a number line. So I draw a line. Okay, I draw a number line on a number line. This is 0, 1. So I take one unit, and at this point I draw another line of 1 unit, 1 centimeter or 1 centimeter, 1 centimeter, 1 centimeter. So if I take 1 and then I join these two lines. So this becomes a right angled triangle, right, with 90 degrees formed here. So as per the Pythagoras theorem, if I take this as one, I name this as OO, A and B, okay, OB square is equal to BA square plus OA square, right? So now this is, what is BA square? BA is 1 centimeter plus OA square is also 1 unit, it is 1 centimeter. So this equals to 1 plus 1, this equals to 2. So OB square is equal to 2. So OB is equal to square root of 2. Right? OB is equal to square root of 2. So now if I keep my compass here and with this length, if I draw an arc on the number line, if I keep my compass point here and take this length and draw an arc on the number line with the compass, this point indicates square root of 2. Right? Now, I hope that clears your understanding of representing square root of 2 on a number line. Now the point comes, how do I represent square root of 3? Right? How do I represent square root of 3? So, hold on. Square root of 3 is nothing but, I can say, square root of 2 plus square root of 1. Right? This will bring me square root of 2 plus 1, 3. So now I already have represented square root. So this is a point. On this point, with this point as my reference, I draw another line which is perpendicular, this is a point. I draw another line which is perpendicular to this line, which is perpendicular to this line. This is 90 degrees. How much is this? 90 degrees. I join this line. Okay. Now, this is already represent point square root of 2. Now, I take this. So, this point is square root of 2. At a length of 1 centimeter, you have taken 1 centimeter and drawn a line. This, you can just imagine that this line is of 1 centimeter. So, this square root of 2 and 1. So, I can say I have square root of 2 whole square plus, I need, if I say O, I name this as point as D. So OD square is equal to this point, this length OB, we have already found out OB is square root of 2. So OB square root of 2 plus this DA, DB is square root of, this is 1, so I have taken it 1 square, right? So this is equal to 2 plus 1, so this is equal to 3. So OD square is equal to 3. So OD is equal to square root of 3. So I keep my compass point at this juncture, take this length and draw a line. There's an arc, there are not a line, sorry, there's an arc, and with this arc you get a point as 3. With your compass point located here, kept here, the point kept here like this compass, you are keeping a point here like this, and take this length from here to here and then draw a line, arc, which intersects the number line, and this point of intersection of the arc and the number line represent root 3. Represents the point of intersection represents root 3. So in this way, imagine the length of root 2, the points of intersection, that is of lie between 1 and 2 on the number line. Okay, they always lie between number 1 and 2 on the number line. I hope you understood how to represent root 5 on a number line. Now let us go forward and try to solve exercise on irrational numbers. Let us see the questions under section exercise 1.2. What does it say? First one, say whether it is true or false. The first thing says, every irrational number is a real number. What does the definition of real numbers say? The definition of real numbers says that the numbers on the number line, that is, it has 0, it has negative numbers, it has positive numbers, okay, whole numbers, everything. So real numbers is a whole set of numbers on the number line. So when you say the whole set of numbers on the number line, then even irrational numbers are on the number line. That is why irrational number is a subset of real numbers. So that is why you can say true, that is every irrational number is a real number. That is really true, because irrational number, I repeat, irrational number is a subset, is a smaller set of numbers on the number line, on the huge, and the number line is such a huge line which has all positive numbers, negative numbers, 0, right? So it's a big set, and from that big set you have just taken a small set of numbers. Those numbers are irrational numbers. And yes, when you say it belongs to that, you have taken from that, right? So it belongs to it. So that is why irrational numbers are every irrational number is a real number. Now next question. Every point on the number line is of the form root 2 root m, where m is a natural number. Is this true? No. Why? The number line consists of positive numbers, negative numbers, while as the natural numbers do not contain negative numbers, nor do they contain 0. Right? When you add 0 to it, it becomes whole numbers. Right? So 0 does not form a part of natural numbers, and negative numbers do not form a part of natural numbers. Hence, every point on the number line, when you say number line, it has positive, negative numbers also. So that is why this particular statement is not true. Every real number is an irrational number. Even this is not true. Why? Every real number, even real numbers, does contain perfect whole numbers. That is, it contains it contains 4, it contains 9, it contains 16, it contains 25, it contains 36, 49, 64, and so on. So just perfect square numbers, perfect square numbers in fact, and they are not irrational. They are not irrational. They can be represented in the form 2, p by q, where q is not equal to 0, and p by q. P and q are integers. So when you say that, so that is why this particular statement, every real number is an irrational number, is not true, it is false. Now, the next question, that is a question number 2. Are the square roots of all positive numbers, are the square root of all positive numbers irrational? Square root of all positive numbers? No. Why? Positive numbers contain perfect numbers also. What are the perfect numbers? 4, 9, 25. As I said, they're all perfect numbers. So these numbers are not irrational numbers. Okay? Square root of all positive square roots. So when I say square root of 4, it is 2. Square root of 9 is 3. Square root of 16 is 4. So they are perfect square roots. That is why. Even this is not true. And how do you prove that it is not true? You can say that if what does it say? The square roots of all positive numbers like 4, 9, 16, 25 are, they are perfect squares, and the square roots of them are perfect whole numbers, perfect natural numbers, which can be represented in the form P by Q, and they are rational numbers, and hence you cannot claim to say that the square root of all positive numbers are irrational. Right? So that is how you explain. The next question is how to represent root 5. I've already showed you how to represent root 5 on the number line. A small for you to hint to keep in mind is when you represent rational numbers on a number line, that is, when you represent root 2 and root 3, the point of intersection of these two numbers is between 0 and 1. 1 and 2 is between 1.1 and 2 on the number line. When you're representing root 2 and root 3, it lies between 0.1 and 2 on the number line. When you're representing root 5, root 6, root 7, root 8, root 5, root 6, root 7, root 8, the point of intersection of this number, irrational numbers, okay, when you're finding root 5, root 6, root 7, root 8, the point of intersection lies between 2 and 3. When you try to represent numbers, square root of 10, 11, 12, 13, 14, 15, square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, and square root of 15, it lies between 3 and 4. The point of intersection on the number lies between 3 and 4. And if when you're trying to represent numbers like, what's that? Yes, that is root 17, root 18, root 19, root 20, root 21, root 22, 23, root 23, root 24. It lies between 4 and 5. Between two perfect squares, right? Between two perfect square roots, that is 4 and 5. Here you have 16 at the lower end, and there you have 25 at the upper end. So 16 is 4 and 25 is 5. So the square root of any of the numbers in between 16 and 25 lie between 4 and 5. So that you have to keep in mind. So with this, I conclude today's session of representing irrational numbers on a number line. So kindly revise on everything, okay, so that you will be able to understand everything. Any doubt, please comment below and I will surely help you. So take care of yourself, don't stress, let's be cool, let's chill, try to understand slowly. If you're not able to understand, repeat my sessions over and over again, then I think it will be clear. If yet not clear, leave your comments and I will surely try to help you. Thank you, take care, God bless.